Good morning all. How are you? I hope all of you are fine. So, today we are going to discuss a new topic called metrics. Maybe some of you have heard about the topic metrics, maybe not. Anyway, today I am going to give a detailed explanation to the concept metrics. Okay? For that, suppose I have some information about the number of notebooks and pen possessed by three of my students named Simi, Ria and Sneha. Okay? So, Simi, Ria and Sneha. Notebooks, pen. Suppose Simi has 3 notebooks and 1 pen. Ria has 5 notebooks and 3 pen. Sneha has 4 notebooks and 2 pen. Okay? So, now we got a tabular data about the number of notebooks and pen possessed by 3 students. Isn't it? Yes. So, here the horizontal entries or the horizontal values constitutes row of the tabular column and the vertical entries constitute the column of the tabular column. Okay. So, here it has 1, 2, 3. 3 rows. So, I am calling the first one as R1, second row as R2 and third as R3. Similarly, it has 2 columns. So, C1 and C2. The same tabular column can be expressed in another form by interchanging the rows and columns. By interchanging the rows and columns, we get another tabular column like making notebooks and pens as rows and name of the students as columns. Then notebooks 3, 5, 4, pen 1, 3, 2. Here we have 2 rows R1, R2 and 3 columns. Isn't it? Now we have 2 set of data. Now I am putting a rectangular array on either side of this data. I am putting this data inside a rectangular array. And this expression of data is simply called a matrix. So, matrix is a representation of given data. We have many other representations for a data and matrix is one of that representation for a given data. Here also we can insert the data inside a rectangular array. So, this is also a matrix. So, what is a matrix? A matrix is a group of data inside a rectangular array and it has rows and columns. Is it clear? Okay. So, now we can give a standard definition for matrix. Here we have rectangular array, rows and columns and some values inside it. So, a matrix is an ordered rectangular array of numbers or functions. That means the data can be either numbers or functions. Here we use numbers. We can also use functions like trigonometric functions, exponential function, algebraic functions. The value can be either numbers or functions. Okay. Then a matrix has rows and columns. Horizontal line of entries are called the rows. Vertical data is called column. Then the numbers or functions. The numbers or functions inside a matrix. That means the values inside this matrix are called as either as elements or as entries. So, each of these values inside a matrix is called an element of a matrix or an entry of a matrix. Okay. So, definition. What is the definition? A matrix is an ordered rectangular array of numbers or functions. This is the standard definition of matrix. And Each of these numbers or functions are called the entries or elements of the matrix. Is it clear? So basically matrix is a representation of data, and it is a method of representing a given data, and it has a standard definition called a matrix is an ordered rectangular array of numbers or functions, and it has rows and columns, and each of these numbers or functions inside a matrix is called an element or an entry of a matrix. I think so far everything is clear, isn't it? Yes. Okay. Now, we said that these are the rows and these are the columns. And have you ever wondered where did the name matrix came? The term matrix was first introduced by the English mathematician James Joseph Sylvester in 1815. He is the one who coined the term matrix. Okay? So, now, consider the linear equation. 2x plus 5y equal to 3, x minus 2y equal to 4. Here we have two linear equations. Now, I am writing the coefficients of these equations. 2, 5, the coefficient of the first equation, and 1 minus 2, coefficient of second equation, and putting it inside a rectangular array. So, this become a matrix. So, we can use matrix in linear equations also for representing a linear equation. It is called the coefficient matrix of the given linear equation. So, matrix has a wide range of application, not only in mathematics and not only in science subjects. It has wide application in non-science subjects like economics, cryptography, and so on. Okay. So, here the linear equation is expressed as matrix. Now, I am moving on to a new topic called order of a matrix. Order of a matrix. In this matrix, we have how many rows? 2 rows. And how many columns? 2 columns. So, for defining an order of a matrix, the definition is not if, for a matrix of m rows and n columns, the order of the matrix is m by n. What is that? The order of a matrix. For a matrix with m rows and n columns, order of a matrix is m by n. It is written as m multiplied by n, but it is read as m by n. That means, for writing the order of the matrix, we have to find the number of rows and number of columns of the given matrix. Then we have to represent it in m by n, this format, and it should be read as m by n matrix. We'll consider this matrix. First, we have to count the number of rows. Here it has how many rows? 2 rows. How many columns? 2 columns. So, the order of the given matrix is 2 by 2. So, it is a 2 by 2 matrix. So, the given matrix is a 2 by 2 matrix. Usually, we represent a matrix or we name a matrix using capital alphabets. Capital letters. Okay. So, we always name a matrix using capital letters. So, this is a matrix A. we can write many other metrics by, always we name the metrics by capital letters. Clear? So to find the order of a matrix, we have to find the number of rows and number of columns of the matrix. Then we have to write first the number of rows and then multiplication symbol and then the number of columns, and we read it as m by n. M is the number of rows and n is the number of columns. So let's check some examples. A equal to 2, 3, 6, 4, 5, 7. Can you find the order of this matrix? It's very simple, isn't it? It has 2 rows. So first we have to count the rows. So it has 2 rows and how many columns? 3 columns. So it is a 2 by 3 matrix. If someone asks you to write a 2 by 3 matrix, you have a matrix with 2 rows and 3 columns. Usually we write the order of the matrix at the right bottom side of the matrix. So it is a 2 by 3 matrix. And the example, what about this matrix? It has 3 rows. 3 rows and 2 columns. The order is 3 by 2. So this is a matrix with order 3 by 2. Is it clear? Okay. Now, there is a note to remember. If a matrix is of order m by n, if a matrix is of order m by n, then it has mn elements. It's an important note. If a matrix is of order m by n, then it has mn elements, that is m multiplied by n elements. What do you mean by elements? Elements are the values we written inside a matrix. So elements are the entries inside the matrix. So what is the relation between the order of a matrix and the number of elements of a matrix? If a matrix is of order m by n, it has mn elements, that means m multiplied by n elements. That means if a matrix is of order m by n, then the number of elements inside the matrix is the product of the number of rows and number of columns. Clear? So let's check is it true in these two cases. Here the order is 2 by 3. So here m is 2 and n is 3. Then according to this condition, it should have mn elements. That means m into n elements. That is mn is equal to here 6. Let's check 1, 2, 3, 4, 5, 6. It has 6 elements. Okay. So in this case, it is true. Now check this one. Here we have 3 rows and 2 columns. M is equal to 3, n is equal to 2. Then by this condition, it should have mn elements. Here mn is equal to again 6. Let's count 1, 2, 3, 4, 5, 6. So here also it is true. So if we know the order of a matrix, we can find the number of elements, total number of elements inside that matrix. Also, if we know the total number of elements inside a matrix, then we can guess the possibilities, possible orders of the matrix. Clear? So if we know the order of a matrix, we can find the total number of elements inside a matrix. Let's take another example. B equal to 3, 4, 6, 7, 8, 11, 13, 14, 17. What is its order? 3 rows, 3 columns. 3 by 3 matrix. Then according to this condition, it should have mn elements means 9 elements. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 elements. Clear? So it has 9 elements. So if you know the order of a matrix, we can easily find the number of elements inside that matrix. Similarly, if you know the number of elements inside a matrix, we can guess the possible order of that matrix. Let's try to solve a problem. Okay. Suppose a matrix has 8 elements, then what are the possible orders of the matrix? Suppose a matrix has 8 elements, then what are the possible orders of the matrix? So, to solve this problem, we have to recall the note we have learned just before, isn't it? That means if we know the order of a matrix, we can find the number of elements. But here, the number of elements is given. We have to find the possible orders. What is the relation between the order of a matrix and the number of elements of a matrix? If the order of a matrix is m by n, then the total number of elements of the matrix is the product of the rows and columns, that is m multiplied by n. So, here we have given that the number of elements equal to 8, that is mn equal to 8. So, if mn is equal to 8 and the order of matrix is m by n, that means we have to find that m and n, possible m and n whose product is 8. We have to find two numbers whose product is 8. What are the possible pairs of numbers whose product become 8? Start with 1. 1 multiplied by one number, or which number gives 8? 8. So, possible orders are, first possibility is 1 by 8. Can be 1 row and 8 columns. Then, second one, 2 by 4. 2 rows and 4 columns. Here also the product is 8. So, the order of the matrix can be 2 by 4. Then third one, 2 by 4. Then 4 by 2. Here, the number of rows and columns reversed. Here 4 rows and 2 columns. Here 2 rows and 4 columns. So 4 by 2. Then the last possibility is 8 by 1. These are the 4 possible pairs. These are the 4 possible orders of the matrix, whose total number of element is 8. 1 into 8 is 8, 2 into 4 is 8, 4 into 2 is again 8, 8 into 1 is 8. So, if a matrix has 8 elements, then the possible orders of the matrix are 1 by 8, 2 by 4, 4 by 2 and 8 by 1. So, clear? Is everything clear? Okay. So, what we have learned today? We learned a new term called matrix. Who coined the term matrix? The term matrix was coined by the famous English mathematician James Joseph Sylvester in 1850. He is the one who coined the term matrix. What is a matrix? It is a method for representing a given data. What is a clear-cut definition or the standard definition of the matrix? A matrix is an ordered rectangular array of numbers or functions where the numbers of functions are called the elements or entries of the matrix. Then what are the specialities of the matrix, or what are the features of the matrix? It has rows, it has columns, then each of these entries is called elements or other entries. Okay. Then what we have learned? Then we learn what is an order of a matrix. If a matrix is of order m by n, then if a matrix has m rows and n column, then the order of the matrix is m by n. Okay. If a matrix has m rows and n columns, then the order of the matrix is m by n. First we write the number of rows, then we write the number of columns and put the multiplication symbol between them, but we read it as m by n. Then what's the next point? We usually name a matrix using capital letters. Capital letter A, B, C, matrix A, matrix B, matrix C, so on. Then we write the order of the matrix at the right bottom corner of the matrix. Then we learn a relation between the order of a matrix and the total number of elements inside a matrix. What is the relation? If the matrix is of order m by n, then it has m n elements, that is m multiplied by n elements, where m is the number of rows and n is the number of columns. So if we know the number of rows and number of columns, we can write the order of the matrix. If you know the order of a matrix, then we can find the number of elements inside the matrix. Also, if we know the number of elements of the matrix, we can guess the possible orders of that matrix. We can't accurately find the exact order, but we can guess the possible orders, what orders that matrix can have. Okay. So I think all the topic we have discussed today is clear for all of you. Okay, in the next class we will discuss the further topics like different types of matrix and so on. So thank you.